So our next speaker is Anna Knack, who is a lead researcher within the Center of Emerging Technology and Security at the Alan Turing Institute. Anna will talk to us about human-machine teaming and intelligence analysis. The floor is yours. It's here.
Thanks, everyone. It's a pleasure to talk about our research on human-machine teaming and intelligence analysis. There's lots of interest at the moment in how to use ML to support intelligence analysts who are sinking under all the large volumes of data that they have to sift through to do their work for the national security community. But at the same time, we need to better understand how these systems work to know if we can trust the outputs that come out of the system, and if the outputs that come out of the system are trustworthy enough to be integrated into the decision-making process in high-stakes contexts. So essentially, for this research, we tried to do three things. First, we wanted to understand where ML is most useful along the intelligence analysis workflow. Second, we wanted to understand what technical and human considerations associated with embedding ML in a system what the technical and human considerations are when we're thinking about integrating ML and intelligence analysis. And third, how the technical attributes and the behavior of the model need to be explained to different types of users, different types of analysts, to provide sufficient confidence in the system. So what you'll see on the screen is a very simplified version of the intelligence collection, or the intelligence analysis process, starting from intelligence collection, collection optimization, and then further to the right, these are the tools where you see more direct decision support tools for defense security decision makers. And based on our research, having engaged with lots and lots of intelligence analysts, behavioral scientists, defense research organizations, academics who are working on world-leading tools, as well as industry, the parts of the intelligence analysis process where ML would bring most benefit is more to the left of the cone. So in characterizing, discovering, and triaging information from large volumes of disparate data. So as one behavioral scientist described to us, most analysts are more comfortable in ML helping them sift through fewer haystacks rather than identifying the needles in the haystacks themselves for the analysts. So there's already lots of really interesting literature on AI explainability, and the black box issue is very widely known across the community. And in most of those explainability articles that we saw through the literature review, often were full of mathematical formulas and technical explanations of how the system works. But as a person who doesn't have a technical background, it was very clear to me that this doesn't help me understand exactly how the model works or how much I can trust the outputs that are coming out of the model. So what does help? So based on our research, the key component to any ML tool that would need to be unlocked before we can deploy it in an operational environment is involving both trust in the output, but also trust in the system that's taking care of the entire tool. So we need to look at these systems from a whole lifecycle perspective, and we need to look at explanations across different levels of the process of integrating the system before deployment, during deployment, and also in oversight and maintenance of the tool. So we identified around 3 generalizable buckets of types of explanations, and I should add the caveat here that this will probably be context specific. You know, like you have lots of different types of intelligence analysts, like a defense intelligence analyst working on a particular operation is going to have a very different use case to someone who's doing criminal investigations, for example. But these are broadly generalizable. So the black column is the type of explanations that you need for the senior responsible owner, as in this is the person who is going to approve the model for deployment. And they need to understand what are the system's limitations and assumptions, what's the historical performance? How accurate has it been? What was the intended use case? Is this being repurposed? And was it intended for a different use case than what we're looking at now? That helps us understand, is it going to work a little bit better, a little bit, is it going to be less reliable than what we might expect? And then any records of access to particular data and how necessary and proportional that was need to be discussed before deployment and not after the fact when something goes wrong. The second column is for intelligence analysts. So if your day-to-day user is prioritizing efficiency, they want simple, plain English, bidirectional communication with the system. They want to be able to challenge the system. They want to be able to ask questions. They want to be able to give feedback. And then oversight bodies want things like explanations of data logs. So like how, like which analyst had access to this tool at what time, and what did they decide based on what type of information. There were also really, really interesting discussions around precision and recall. At the moment, a lot of these decisions are left to industry developers if we're looking at a tool that's off the shelf. But there are really important considerations to be made about what the more costly error is in every given context. Is it a false positive or a false negative? So if you have a discovery related use case, then maybe the tolerance for getting things wrong is a little bit higher. If it's going to inform decisions that kick down doors and arrest people, or that inform targets, then you might want a higher level of accuracy. And the appropriate threshold for any given model is going to be highly context-specific. So how do you arrive at those considerations? You need to be talking to the analysts. You need to be talking to the policymakers. You need to be talking to everyone who has promising practice and lessons learned to share about how to build these tools responsibly. And analysts should be included in the prototyping and testing of these systems. That's it from me. If you want to read the full report, it's available on cetas.turing.ac.uk.